Welcome to Final Exam Practice Part 3, the Extended Response section. Okay, so this one has a little bit longer of instructions, but you're going to have 1 hour and 10 minutes to complete the extended response. This is the one that you're going to do live on Zoom on Wednesday, April 29th from 10 to 11:10. You're going to complete each problem just like you did with Test 3. All of the problems, though, on this, except number 2, are going to require you to show your work. So copy your original question on a blank piece of paper, and then you'll have half an hour after the test closes to email me. So you need to email me by 11:40 a.m. all of your work. So we're going to go through these 11 questions. Question number 1 is find the equation of the line through 2 points. Okay, so let me get this up on the whiteboard. Okay, so here's question number 1. We have 2 points. You need to take the 2 points you are given and come up with the equation of the line through these 2 points in slope-intercept form. So step 1, find the slope. So to find the slope, you're going to use the slope formula. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then just take these 2 points and label the coordinates. X sub 1, y sub 1, x sub 2, y sub 2. And now replace y sub 2 and y sub 1 into the numerator here. 2 minus negative 3. For the denominator, you have x sub 2 minus x sub 1, so 1 minus negative 3, and that gives us 5 over 4. So step 1 was find the slope. Step 2 is you're going to use point slope form. Now you don't have to do it this way. If you want to use slope-intercept form and do a substitution and solve for b, you can. But this is a pretty straightforward method, okay? So 2, use point slope form, and you can have this in your notes. Y minus y sub 1 is equal to m times x minus x sub 1. So all you do is you take your slope value, you replace m with your slope, and then for x sub 1 and y sub 1, you can pick either point. It doesn't matter, okay? So you can pick this one, although I don't like it because it's got 2 negatives. So if you can use some positives, that's nice. So you just plug in the x coordinate and the y coordinate of one of the points. Just be consistent to use the same point both times. Here's the x coordinate of the point and the y coordinate of the point, okay? So once you get that equation in point slope form, then step 3 would be to solve for y. So to get y by itself, we have to start by using the distributive property here. Now remember, this is extended response, so you have to email me all your work. So you want your work to be labeled with the question number. You want to have all your work done in a good presentation, legible, all of that, okay? So after you use the distributive property, then we need to add 2 to both sides. When you add 2 to the left, you can just write plus 2. You don't have to show adding 2, you can just do it mentally. But I wanted to show it here because when you add 2 to a fraction, remember you need to have a common denominator. So 8 over 4 is the same thing as 2, but I can add 8 over 4 to negative 5 over 4 because now they have the same denominator. So y is equal to 5 fourths x, and negative 5 fourths plus 8 fourths is a positive 3 fourths. So I'm going to take this answer and plug it into my Open Math, and then this would also be emailed. So I have 5 force x plus 3 force. So that's the steps for coming up with the equation of a line through 2 points. Okay, question number 2 is the only question you do not have to show your work for. You're going to take these 2 lines and you're going to graph them. So what you would want to do is to consider how to graph each of these lines. You can either use, let me show you 2 different methods for graphing a line. One method is to get y all by itself. And so if you transform this first equation to get y by itself, you get y is equal to 2x minus 2. Okay, so if you have the equation y equals 2x minus 2, you can see that the slope is 2 and the y-intercept is negative 2. So to graph that one, 2x minus 2, you're going to start at the y-intercept negative 2, and you go up 2 over 1. So up 2 over 1, up 2 over 1, and that gives you your equation. Okay, so that again, right there, that line that I just graphed is y equals 2x minus 2. The y-intercept is at negative 2 right here. The slope is positive 2, up 2 over 1, up 2 over 1. So I got that equation by transforming this first equation. All right, that's the same thing. Another way you can graph a line is to use intercepts. So for this second one right here, let me use this method right here, where you take your x and your y, you plug in 0 for x, you plug in 0 for y. So if you plug in 0 for x for this, you end up with y is equal to 3. And if you plug in 0 for y, you have 3x equals 3, and 3x equals 3 means that x is equal to 1. So now I have the points 0, 3, and 1, 0. 0, 3, 1, 0. So 0, 3 is this point right here, and 1, 0 is this point right here. So whatever method you use to graph, you don't have to show your work. You can choose any method that you want. Just make sure you graph your lines correctly, okay? And then once you graph your lines, then you're going to write down the solution. And the solution is the point where they intersect. So right here you can see that the 2 graphs cross at, sorry, I should not have done that last line. Okay, so what happens if you end up with more lines than you wanted? You can do clear all, and you can start again. So I had one of them at here to here. The other one was 0, 3, and 1, 0. Ta-da! Okay. So these 2 graphs intersect here at this point. And the point is the solution of the system. And that point is 1, 0. So I'm going to type in the point 1, 0 right here. Okay, I was not meaning to do that. Let's get rid of this pencil real quick. And we have 1, 0. Now, I have to use parentheses to have correct notation. There you go. Now, question number 3 is also a system of linear equations, but you're going to solve it algebraically. So let me get question number 3 up here on the whiteboard. Okay, here's question 3. We are solving the system of equations algebraically. I'm going to show you 2 different methods. So method number 1 is using substitution. If you use substitution, what you have to do is get one variable by itself. So this is the easiest variable to get by itself because it already has a coefficient of 1. So substitution is a nice method if you already have a variable with a coefficient of 1 or even negative 1. Both of those are convenient. So I could rewrite this equation as x equals 6y plus 52. Now make sure all of your work is really well organized. And don't attach these by an equal sign. These are not equal as written. Otherwise, it would. If you have an equal sign right here, what you're doing is you're saying that x is equal to 52. X is not 52. So just do an arrow. Now what that means is I can now replace the x in the second equation with what x is equal to. So I'm going to take this 6y plus 52, and I'm going to replace the x in the second equation by 6y plus 52. So now I rewrite that second equation. Here's the second equation, but instead of writing x, I write 6y plus 52. So then this gives me negative 18y minus 156 plus 4y is equal to negative 58. So if I combine like terms here, I have negative 14y and add 156 to the other side, and I have a positive 98. And then when you divide both sides by negative 14, 98 divided by 14 is 7. So y is equal to negative 7. That's not the answer, that's just the y coordinate. So to get the x coordinate, go back to this equation right here, okay? So the equation we had up there was x is equal to 6y plus 52. Replace your y with negative 7, and now you have negative 42 plus 52 is equal to 10. So once you find your x coordinate and your y coordinate, then the answer is going to be actually a point. 10, comma, negative 7. So that was method number 1, substitution. You only need to use one of the two methods, so I'm going to review both methods and you can choose which one you like. Okay, so let me show you this again using method number 2. Okay, so method number 2 is elimination. This is my favorite of the two. Elimination has you multiply one or both of the equations by some number to create a least common multiple with opposites that can cause you to eliminate one of the variables. Now, if that sounds complicated, it's really not that bad. Look at the least common multiple of these two numbers, 1 and negative 3. The least common multiple of 1 and negative 3 can either be negative 3 or positive 3, okay? Over here, least common multiple of negative 6 and positive 4 is either going to be negative 12 or positive 12. You want opposites. So we either need a 3 and a negative 3, or a 12 and a negative 12. If we go for 12 and negative 12, that means I need to multiply the numerator by a 2, not the numerator. I need to multiply the first equation by a 2 and the second equation by a 3, which I can do, but that's going to be more work than if I just multiply this top equation by a 3. So if I multiply this top equation by 3, remember, you have to do it on both sides. Use correct notation. That's really important. Now I can rewrite this system. The second equation did not change at all. The first equation becomes 3x minus 18y is equal to 156. So then I just add each column, the positive 3 and the negative 3x. I purposely set it up that these would be opposites. That was the whole motivation of multiplying by 3. The purpose of multiplying by 3 was to create opposites, because opposites cancel when you add them. So 3x and negative 3x go away, no more x. Negative 18y and a positive 4y is a negative 14y. And then here, 156 minus 58 is 98, and you get back to y equals negative 7. So then once you have one of the variables, then you just plug this back into either of the equations. It doesn't matter which. For simplicity, I'll plug it back into the first one. So the first equation was x minus 6y is equal to 52. And if I replace y with negative 7, I'll be subtracting 42 from both sides. And that's going to give me x is equal to 10. So then my final answer is, again, 10, negative 7. So let me put this into MyOpenMath. You just have to pick one of these two methods. It may be worthwhile to practice both of them, but you only have to use one of the two on the test. So pick one of those two methods, learn to show your work entirely well, and once you can show your work really well, then you can go ahead and be confident with that method. Okay, question number 4. This is an absolute value equation, and I'm going to put this one also up on the board. So here's question number 4. The first thing you want to do for an absolute value equation, step 1, is to get the absolute value by itself. Okay, we want to get it all by itself. So that means I need to add 15 to both sides. So when I add 15 to both sides, I end up with, I'm going to rearrange this. I like the absolute value on the left-hand side. Okay, so once you have your absolute value by itself, then step 2 is to remove the absolute value bars by splitting into two equations. You're going to have the positive version and the negative version. So we're going to split this into two different versions. Do not put the plus or minus right here. It's not time for it yet. You do it after you remove and split. Okay? So on the left, this stays negative 3z plus 12. In both cases, it stays negative 3z plus 12. The difference is that one of these is going to be a positive 33, and one of these is going to be a negative 33. So you have the split between the positive and the negative. Then you solve. Step 3 is to solve each. So we begin by subtracting 12 from both sides. Subtracting 12 again over here. Then divide both sides by negative 3. So we end up with z is equal to negative 7, or z is equal to 15. So that's the work you would want to show on that. So negative 7 or 15. Okay. Next, you're going to solve question number 5, which is the equation p cubed minus 225p. And by the way, remember there are videos and written examples, and so you can look at how to do that. So that one doesn't have a long written example, but you have a video right here to watch me. Okay. So next what we want to do is we want to do number 5, which is the equation p cubed minus 225p is equal to 0. So I'll go ahead and just do it right here. So the way we do this is you begin, step 1 is to factor out the GCF, okay? So step 1 is always look for the GCF, and if you find a GCF, always factor it out. So in this case, the GCF is p. So that leaves us with p squared minus 225. And that's still equal to 0. Now remember, do not divide by a variable. We talked about this in the previous review, part 2. Do not divide by a variable. Okay, step 2 is you want to factor completely, okay? So once you've pulled out your GCF, now you're going to factor. How do we factor p squared minus 225? P squared minus 225 is a difference of squares. Remember, if you have a squared minus b squared, a squared minus b squared is called the difference of squares. and it factors into a plus b a minus b. So we're going to continue to have p out in front. Don't drop that variable. And we're going to factor this into p plus 15 times p minus 15. Why? Because 15 squared is 225. Step 3 is to use the zero factor property. Zero factor. That means that each one of these could equal 0. So we have p is equal to 0, or if p plus 15 is equal to 0, then that gives us p is equal to negative 15. Or if this last factor, p minus 15, is equal to 0, then that means p is equal to 15. So that means we actually have 3 different solutions: 0, negative 15, and positive 15. So let's go ahead and put those in. 0, negative 15, positive 15. Okay, question 6. Definitely we're going to put question 6 up on the whiteboard. So what we have here in question 6 is one of the harder concepts in the class. It's how do you solve a rational equation? This is called a rational equation. The first thing you want to do with a rational equation is you want to factor the denominators. Here we only have one denominator to factor, so we're going to copy everything else as is. It's not surprising that the factorization is going to match these other denominators. These problems are set up to be very accessible at the Math 105 level. Okay, so you should just double check that this is in fact this, and you can do that with FOIL, but it's going to be very likely that these will be the same. Now what you want to do is come up with a common denominator, or go ahead and clear both sides by multiplying both sides by that common denominator. So let me put the equal sign actually right here. So what I want to do is I want to multiply both sides by the LCD. And the LCD is going to be x minus 9 times x plus 7. So I'm going to multiply both sides by x minus 9 times x plus 7. And I have to write this really small because of space, but this is what I'm writing each time, x minus 9 times x plus 7. You'll have more space on your paper. I'm limited with the whiteboard because I need to write big enough so that you can see it. Okay, so make sure that your multiplication is in line with the text, not up in a high position like an exponent. So what happens when you multiply both sides by the LCD? Well, here on the right-hand side, the LCD is going to entirely cancel the denominator, right? And so on the right-hand side, you'll be left with simply 9x plus 37. That's the easy side. The other side's a little harder. So when this x minus 9 times x plus 7 distributes, you're going to have 2 different cancellations happen, okay? So first, when x minus 9x plus 7 multiplies to this first one, the x minus 9s are going to cancel, leaving you with just the x plus 7, and that x plus 7 is going to distribute to the numerator here, x, okay? And then, when x minus 9, x plus 7 multiplies the second time, The x plus 7s will cancel, leaving you with the x minus 9. And now this will be multiplied to the numerator over here, 1. And if we go ahead and expand that, we end up with x squared plus 7x minus x plus 9. And on the right-hand side, 9x plus 37. So here we have a quadratic equation. In order to solve this quadratic equation, we want to get everything on one side. So we need to find two factors of 28 that differ by 3. And those two factors are 4 and 7, with 7 being negative and 4 being positive. Zero factor property, x is equal to 7, or x is equal to negative 4. Okay, so what we want to do is check that this actually works. And so you can plug these into both sides of the equation using a calculator. So if I plug in 7 first of all, 7 divided by 7 minus 9 minus 1 divided by 7 plus 7, the left-hand side is equal to negative 3.57 dot dot dot. Now if I plug that into the right-hand side, 9 times 7 plus 37, and for my denominator divided by 7 squared minus 2 times 7 minus 63. The right-hand side is also equal to negative 3.57 dot dot dot. So that's good. You can test right there on your calculator. Here we go. You can type into both sides your answer, and you should get the same decimal approximation for each. So if you have time to do this, I highly recommend you do this. You can catch your mistakes. Part 3 is worth 50% of your grade. That's a lot. And there's only 50% of the final exam grade, not 50% of the entire grade for the semester. The entire semester grade, though, is a big part of that is the final. The final exam could be worth anywhere from 25 to 40% of your final exam, of your whole semester grade. So you do very, 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 very much want to get all these answers right. So if time allows, check your work. So now I'm going to do the same thing with negative 4. Negative 4 divided by negative 4 minus 9 minus 1 divided by negative 4 plus 7. And that is about negative 0.025. Now the right-hand side, 9 times negative 4 plus 37 divided by negative 4 quantity squared minus 2 times negative 4 minus 63. And I get the same decimal approximation. Great, so the answer is 7 and negative 4. We've tested them both. 7, negative 4. Awesome. Okay, question 7 is a radical equation, so we'll get that one up on the board. Okay, so here we go with question number 7. This is a radical equation. The square root is already by itself, so next we just square both sides. Here's the work that you would show for squaring both sides. And now on the left-hand side, you have 6x plus 51, and on the right-hand side, x squared plus 8x plus 16. Now we have a quadratic equation, so we need to get everything on one side. So we need two factors of 35 that differ by 2. We have a positive 7 and a negative 5, so x is equal to positive 5 or negative 7. Now we absolutely have to plug these in and check them, okay? We don't want an extraneous solution. So let's first plug in 5. 6 times 5 plus 51, 5 plus 4. So here we have 30 plus 51, which is 81, and the square root of 81 is 9, so that one works. Now let's plug in the other one, negative 7. So 6 times negative 7 plus 51 simplifies to 9. And then we have negative 7 plus 4, and that is negative 3. The square root of 9 is not negative 3, so what that means is my final solution is just going to be x is equal to 5. So now let me go to my open math, and I plug in just 5. Question 8, you solve this using the square root property. Okay, let me zoom in a bit on this. Okay, so what you want to do is simply take the square root of both sides. So take the square root of the right and on the left. When you take the square root, you're going to also do this plus or minus sign there on the right hand side. And you should be able to squeeze that in right in here. Okay, so the result, don't use an equal sign, just either go vertically downward, or if you go horizontally, then use this arrow. You end up with y minus 5 is equal to plus or minus the square root of 33. That's because the square root cancels the square. They're inverse functions. So now we want to add 5 to both sides. When you add 5 to the left-hand side, you get y all by itself. When you add 5 to the right-hand side, now you have 5 plus or minus root 33. Now it says to separate multiple solutions with commas, so we're going to write 5 minus root 33 as one of our solutions, and we're going to write 5 plus root 33 as our other solution. Okay, so let's do that. 5 minus root 33 and 5 plus root 33. So here is 5 minus root 33 and 5 plus root 33. I should have figured this out earlier. I can zoom in. This is very exciting. Okay, so that's a lot better to see that. Now let's look at this next one. Okay, so we still want to show work on all of these. This should look very familiar. This problem was on your last test. The difference is, on the last test, you only had to show work for part D. For the final exam, you have to show work for all parts, okay? So let's work through this one on the whiteboard. Okay, so the first part is, I didn't even write down the whole problem here. Okay, the first part is to do f of negative 2, and then we find the vertex. Okay, so part A is f of negative 2, and so the work you're going to show is plugging in negative 2, okay? So you're going to have this opposite sign out in front. Make sure you have all of this written down. This is the evaluation step that you show, okay? Show all of that work, and then you can go straight to the answer. So if you want to do it in your head, you can. If you want to do it on the calculator, you can. Either way, you should get, let's see, negative 63. For part B, we're trying to find the vertex. So to get the vertex, remember, you use the vertex formula. So show using the formula. Formula is negative b over 2a, and that will give you the x-coordinate of the vertex. So negative b over 2a. And that gives you a positive 6. So that's the x-coordinate of the vertex. So now what you want to do is you want to plug 6 into the equation. You want to find f of 6. And f of 6, you don't have to show plugging this one in. You've already shown me that you know how to do that in part A. You can just type it in the calculator. I got 1. Okay, so that means that the vertex is the point 6, 1. So that's part A and part B. Part C is to find the y-intercept, and part D is to find the two values that make f of x equal to 0. So the y-intercept is really easy. The y-intercept, remember, is always going to be the c value. And so in this case, the y-intercept is the point 0, negative 35. And lastly, oh, and you can get that by using this, right? Plug in 0 for x, you get negative 35 for y. So that's the y-intercept. For part D, you want to find the values of x that make f of x equal to 0. That's a fancy way of saying find the x-intercept. So part C is for the y-intercept, part D is for the x-intercept. So now we're going to set our equation equal to 0. Now, it's possible that this factors, and it's possible that it doesn't. I recommend you do multiple versions of this test. Sometimes you could get one that factors, sometimes you won't. So if you get one that factors, awesome. But if you get one that does not factor, you have to use the quadratic formula. So you need to be prepared to show me the work either way, okay? It will just be luck of the draw. Now here, if you want to factor, you're going to have to pull out the negative first. So we need two factors of 35 that add up to 12, and that would be 5 and 7. So we end up with x minus 5, x minus 7, and so you can see here that the two values of x are going to be 5 and 7. So those would be the two values that we're going to put into the on my open math. But in case it doesn't factor, remember you have to know how to use the quadratic formula. So let's review that real quick. The quadratic formula requires that you first identify a, b, and c. A in this case is negative 1, b is 12, and c is negative 35. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this becomes negative 12 plus or minus 144 minus 140. Nice. Which is 4, square root of 4. Okay, so then this becomes negative 12 plus or minus 2 over negative 2. And that is either negative 12 plus 2, negative 10 over negative 2, or if you have negative 12 minus 2, negative 14 over negative 2, which becomes a positive 5 or a positive 7, which is what we already saw. So practice doing it with this, practice multiple versions, and try it with the quadratic formula as well as factoring, depending on the problem that you get, and be prepared to do it either way. Okay, let's go enter these answers now. So the value of f of negative 2, we had negative 63. The vertex, we said, was the point 6, 1. The y-intercept, enter a point. Okay, 0, negative 35. Sometimes if you want directions, it will just say it right there underneath the box. And then here we have 5 and 7. So these you don't write as a point because you're looking just for the x coordinates. Okay, now this NASA rocket problem, question number 10. Let me get this one up on the whiteboard. Okay, so NASA launches a rocket at t equals 0 seconds. That would be the beginning of the launch. And the height is in meters, not feet. That's why it's a negative 4.9 and not the typical negative 16. That's because acceleration due to gravity in meters per second squared is 9.8 meters per second squared, and this is always half of gravity. So as a function of time, here's your height in meters, and we want to know when does the rocket splash down. So when would we have a height of 0, because the height is above sea level. And then how high above sea level does the rocket get at its peak? So these are two separate questions. So first, when does the rocket splash down? The rocket is going to splash down at a height of 0. So we're going to take this same equation and copy it with the height replaced with 0. You're clearly going to have to use the quadratic formula here, okay? So instead of x equals, it's t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the good thing is we're going to get a decimal approximation. So don't round too much along the way though. You don't want to end up having rounding errors. Let's try to simplify this radical though. 40 squared minus 4 times negative 4.9 times 388 is going to give me a pretty big number here. Negative 40 plus or minus the square root of 9204.8. So far I have not rounded. And this becomes negative 9.8 in the denominator. Okay, so we're going to try it with the plus version and the minus version. If you try, first you type into your calculator, you just type it like this. Negative 40 plus root 9204.8 close parentheses divided by parentheses negative 9.8. So try it first with a plus and then with a minus. And remember, this is time. So if you get negative time, that's a problem. You just reject any answer with negative time. 9204.8. So far I've not rounded at all. Okay, so when I did this with a plus, I got about negative 5.7, which is not a good value for splashdown. So I'm going to try it again with the minus. So minus will give you a minus divided by a minus. And with the minus, you end up with 13.87 seconds. So let's go back to here. We have 13.87 seconds. It doesn't tell us where to round to, so I guess we'll find out. But remember, in your work, you're going to have work for me, and that's going to help me see whether or not you ended up with the correct work or you just really messed up somewhere along the way. I don't know, but I do read your work, and so you get credit for what you enter and for your work. Okay, so now we want to know, where does the rocket peak? The peak of the rocket occurs at the vertex, because if you have a rocket and it goes up and then it goes back down, the top of the path of the rocket is going to be the vertex of the parabola up here. So what we want to do is find the vertex of the parabola. And to get the vertex of the parabola, let's go back to the big screen. So vertex, remember, is negative b over 2a. So we have negative 40 over 2 times negative 4.9. Now what this will do is it will tell us the time that the rocket peaks, because this is the x-coordinate, or in this case the t-coordinate, of the vertex. So negative 40 divided by negative 9.8 is about 4.0816. 4.0816 seconds. Okay. I was pausing to see if that even makes sense intuitively. Now, if you think it's going to peak halfway, that would only be true if the rocket starts off at sea level. If the rocket starts off at sea level and then goes up to its peak and then goes back down again, then it's true that the rocket will peak halfway between 0 and splashdown. However, this rocket was not shot from sea level. I can see that from the original equation. It was set off from a height of 388 meters, which means that you're actually going to peak earlier. It's like this. You've got a projectile that goes like this. Okay? So when you get to the peak, it's actually going to happen before the halfway point of the splashdown. And that's what we see here. So what you're going to do then is take the peak time and plug it into the original formula. Negative 4.9 times, here's that peak time. And you can use the answer button on the calculator. It's a really handy button to use. Negative 4.9 times answer squared plus 40 times answer plus 388 gives us about 469.63 meters. Make sure that the peak is higher than the initial height of the rocket. The initial height of the rocket was 388 meters. So the fact that it's peaking this high, it's higher than 388. Okay, so what we're going to do is we're going to go plug those values in. So here it peaks at, we're going to say 469.63. And I, just as a default, tend to round to 2 decimal places unless I'm told otherwise. So next, the last question is function composition. Okay, so definitely we're going to put that one up on the whiteboard. So for question 11, I made this one only worth 2 points, or 2% ultimately of the final exam, as opposed to like 4 or 8%, because it's one of the harder topics that happen at the end of the course, even after test 3. We're going to look at function composition, okay? So first, we need to find f of g of x, which is the same thing as if we had f, and into f we plugged g of x. So the f function right here, let me copy this. We're going to take the f function, and instead of substituting a single value in for x, we're going to actually take the entirety of g of x and plug g of x into each one of these spots. Now g of x is negative 5x minus 3. So what this ends up being, first we got to square this binomial, 25x squared, that becomes 30x plus 9. And then over here this becomes, let's see, positive 25x, and then a negative 5 times negative 3 is 15 minus 9 is 6. So this becomes negative 75x squared. Negative 90x plus 25 is negative 65x. Negative 27 plus 6 is negative 21. I'll find out shortly if this is right when I type this in. But there is your f of g of x. And now to get g of f of x, you're going to take the g function, and into the g function you're going to plug the f function. So the g function is just negative 5x minus 3. And so instead of plugging in a single value here, we're going to plug in the entirety of the f function. And the f function is negative 3x squared minus 5x minus 9. So this becomes 15x squared plus 25x plus 45 minus 3 plus 42. So I'm not going to erase this. In case I get these wrong, I'll be able to check where I made my error. Let's go back over here. F of g of x is negative 75x squared minus 65x minus 21. And g of f of x is 15x squared plus 25x plus 42. Okay, so now I'm going to submit all my answers and see if I get them right. Okay, so I did. Oh, hold on. It looks like I have a small error here in question 2. So if you ever need to see what you got wrong, you go to reattempt assessment. It's not actually going to let you reattempt the assessment for points, but you'll be able to see what you got wrong, okay? They should just label this, see what you got wrong. But nonetheless, that's where you go. Reattempt assessment. Okay, I want to see what I did wrong here. Okay, so what they're saying is that I did something wrong with the graph. So let's look at the graph. Okay, you can see that my graph also goes through the exact same points as their graph, which means that this graph was just being really hypersensitive. And that's exactly the kind of thing that I look for on tests and quizzes when I go and finalize the grades, is I check to see if they mark you wrong here, is the graph that you graphed pretty much exactly the same thing and you just maybe were off by a hair? And if that's the case, I give you full credit for it, no problem. So here, if I'm grading this, I'm going to overwrite it and I give full credit here. But the good news is all the rest of the answers were correct. So you can go back through the video and you can go back and see how I did the work. And remember, if you want extended explanations, sometimes you can get them from these MyOpenMath videos, but you also have the videos that I've posted on YouTube that you can go back and review. All right, well, this was the last lecture for the class. Hurrah! And now I know you have a big job ahead of you to review for the final exam. And if you can go through these lectures multiple times, I think they can really help prepare you. I was very encouraged to see the number of views for the Test 3 review, so I am encouraged that you students are taking this very seriously and you're using these reviews multiple times, and I hope the very best for you. I will see you on Wednesday the 29th at 10 o'clock on Zoom.